Empennage. The empennage, commonly called the tail assembly, is the rear section of the body of the airplane. Its main purpose is to give stability to the aircraft. The fixed parts of the horizontal stabilizer and vertical stabilizer are fin. The front fixed section is called the horizontal stabilizer and is used to prevent the airplane from pitching up or down. The rear section is called the elevator and is usually hinged to the horizontal stabilizer. The elevator is a movable airfoil that controls up and down motion of the aircraft's nose. The vertical tail structure is divided into vertical stabilizer and the rudder. The front section is called the vertical stabilizer and is used to prevent the aircraft from yawing back and forth. The principle behind its operation is much like the principle of a deep kill on a sailboat. In light single-engine aircraft, it also serves to offset the tendency of the aircraft to roll in the opposite direction in which the propeller is rotating. The rear section of the vertical structure is the rudder. It is a movable airfoil that is used to turn the aircraft. Sometimes the fixed stabilizer and separate movable elevators are replaced by a single moving horizontal tail known as a stabilator. The Piper PA-28 is an example. The picture shown is the column in straight and level flight. Pull back to climb, push forward to descent. This picture shows the tail section having a horizontal stabilizer, vertical stabilizer, and a elevator attached to the horizontal stabilizer and a rudder hinged to the vertical stabilizer. Rudder is used to turn the aircraft left and right, that is called yawing, and the elevator is used to pitch the aircraft up and down. The fixed stabilizer, separate movable elevators are replaced by a single moving horizontal tail known as a stabilator. Piper PA-28 is shown in the example. If we don't move the control stick, the flight will be in straight and stability. It is in the level flight. If we pull back the control stick, the aircraft moves upwards. That is, if we pull the control stick, pull back the control stick, the aircraft pitches up. If we push forward the control stick, the aircraft moves down, that is, the aircraft descends. Horizontal stabilizer moves downwards. Another variation is to combine the vertical fin and the stabilizer into one pair of controls, 2 instead of 3, which form a V shape known as a V-tail. The theoretical advantage of this design is the reduced interference tag associated with 2 surfaces instead of 3. On the V-tail, the combined rudders and elevators are known as Ruddervators. The engineering is more complicated in this system. The early Beechcraft bonanzas are an example. Actually, in this, the rudder and elevator is combined together as a V-shaped tail section. This diagram shows a butterfly or V-tail tail section of an Beechcraft bonanza. This is the elaborate view of the Beechcraft bonanza aircraft. Both rudders down, aircraft pitches down. Both ruddervators down, so that aircraft pitches down. Both ruddervators up, so the aircraft pitches up. Right rudder down means aircraft yaws right. Left rudder down means aircraft yaws left. Normally in horizontal stabilizer and vertical stabilizer, in horizontal stabilizer, if both the elevators are down, aircraft pitches up, aircraft pitches down. But in the ruddervators, it is an opposite to the elevators. Because of their aerodynamics is more complicated than that, due to the V-shaped form that have the aerodynamics of air passing through the airfoil. Tailless aircraft. Although the conventional aircraft described above represent 95% of all the world's aircraft, some of the most important designs are tailless. Concorde, The AVRO, Arrow, and the Space Shuttle are three notable examples. As you maybe have noticed, they are all supersonic aircraft. In the future, when supersonic flight becomes more common, we will probably see more tailless aircraft. On the tailless aircraft, the pitch controls and roll controls both be on the wing. There can be separate elevators and ailerons, or they can be combined into one set of controls known as ailerons. In the tailless aircraft, the tail section is eliminated, and it is included in the wing itself as elevators and ailerons. It is called as ailerons. The picture shown is the wing of an aircraft having ailerons. The center part is the rudder portion. The tailless aircraft still usually has a vertical fin with a rudder. Canard aircraft. A canard aircraft is one in which the horizontal stabilizer and the elevators are ahead of the main wing. Such aircraft still have the same control as the conventional aircraft. They are just in different places. The aircraft below has two vertical fins and two rudders on the tips of the wings. An interesting side note about this design is that the left rudder pedal operates the left rudder and vice versa. The rudders only extend outward. Both rudders can be deflected at once by pushing the rudder pedals together, thus acting like we can see the canard aircraft in the picture. Here, the horizontal stabilizer and elevators are at the nose portion of the aircraft, that is ahead of the main wing, and it helpful for pitching the aircraft up and down. The rudder is located at the tip of the main wing. Thus, the left rudder is operated by the left pedal by the pilot. Right rudder is operated by the right pedal by the pilot. Left pedal is used to turn the aircraft left. Right pedal turns the rudder right so that the aircraft turns right. If both the pedals or left and right pedals are pressed together, the aircraft acting like a drag brakes. It is used to control the speed of the aircraft. Structurally, the empennage consists of the entire tail assembly, including the tail fin, the tail plane, and the part of the fuselage to which these are attached. On an airliner, this would be all the flying and control surfaces behind the rear pressure bulkhead. The front, usually fixed section of the tail plane is called the tail plane or horizontal stabilizer and is used to provide pitch stability. The rear section is called the elevator and is usually hinged to the horizontal stabilizer. The elevator is a movable airfoil that controls changes in pitch, the up and down motion of the aircraft nose. Some aircraft employ an all-moving stabilizer, and the elevators in the unit are full flying stabilizer. The vertical tail structure or fin has a fixed front section called the vertical stabilizer, used to restrict side-to-side motion of the aircraft yawing. The rear section of the vertical fin is the rudder, a movable airfoil that is used to turn the aircraft's nose to one side or the other. When used in combination with the ailerons, the result is a banking turn, often referred to as a coordinated turn. Some aircraft are fitted with a tail assembly that is hinged to pivot in two axes forward of the fin and stabilizer, in an arrangement referred to as movable tail. The entire empennage is rotated vertically to actuate the horizontal stabilizer and sideways to actuate the fin. The aircraft's cockpit voice recorder, flight data recorder, and emergency locator transmitter (ELT) are often located in the empennage because the aft of the aircraft provides better protection for these in most aircraft crashes. Trim. In some aircraft, trim devices are provided to eliminate the need for the pilot to maintain constant pressure on the elevator or rudder controls. The trim device may be a trim tab on the rear of the elevators or rudder, which act to change the aerodynamic load on the surface, usually controlled by a cockpit wheel or crank. An adjustable stabilizer, into which the stabilizer may be hinged at its spare and adjustably jacked a few degrees in incidence either up or down, usually controlled by a cockpit crank. A bungee trim system, which uses a spring to provide an adjustable preload in the controls, usually controlled by a cockpit lever. An anti-servo tab used to trim some elevators and stabilizers as well as increased control force field, usually controlled by a cockpit wheel or crank. A servo tab used to move the main control surface as well as act as a trim tab, usually controlled by a cockpit wheel or crank. Multi-engine aircraft often have trim tabs on the rudder to reduce the pilot effort required to keep the aircraft straight in situation of asymmetrical thrust, such as single-engine operations. Actually, in some aircrafts, in the elevators and the rudders, a trim devices are used, such as trim tabs or adjustable stabilizers or a bunchy trim system, servo tab. Like this, categories or types are used in horizontal stabilizer and vertical stabilizer. Actually, these trim tabs are used for eliminating the constant pressure on the elevators or rudders. The aerodynamics is eliminated in the horizontal and vertical stabilizers.